Health Core Facility here at KI, and I'm hosting this seminar series together with Åsa Kallas from KI Innovations. So why do we see a need among researchers working in healthcare to learn more about creating impact, that is taking your innovation from research to actual patients? We believe that there's a lot of great eHealth innovations at KI, but researchers find it difficult to implement these solutions in clinical care. And we would like to inspire you and show you different ways of doing this and give you some useful hints along the way. So this seminar series will cover some of these issues and the solutions to these issues. And today we're starting by discovering the values within your digital health project, asset inventory and means of protection. But before we start, just some reminders. Please be active, raise your hand or use the chat to write your questions. I will be keeping an eye on the chat to make sure that you can participate if you wish to do so. Otherwise, please keep the mic on mute. We will also distribute copies of this presentation today, and this seminar will be recorded, so you can get instructions on where to find the recordings if you wish to have a look afterwards. So now Åsa will tell us a little bit about KI Innovations. Please, Åsa.
Thank you, Lee. Innovation support at Karolinska Institutet. KI Innovations is providing innovation support to students, researchers and startup companies at Karolinska Institutet on behalf of Karolinska Institutet. And you can take the next slide, Lee. And innovation and impact creation are actually very important missions for a university. And this is strongly encouraged by the leadership at KI. And in the picture, you can see the front page of the Strategy 2030 from Karolinska. And in this document, it's stated that translating research into clinical practice is an obvious part of a medical university's mandate. You can take the next. And if we look at the role of academia when it comes to providing new innovative ideas, this picture is taken from the Swedish Drug Discovery and Development Pipeline report developed by Sweden Bio. And it shows that out of 148 Swedish R&D companies, 2/3 of these companies are spin-outs from academia and or hospital, and it points towards the importance of the university as a source for innovation. Now this is for pharma and biotech, but I would imagine that it looks similar for digital health. You can take the next. So if we look into the innovation support provided by Karolinska Institute Innovations, we work through the entire value chain. So from inspiration and information to validation of potential for impact creation to incubation of startup companies. And we do this by providing advice and coaching. We have access to some early financing. We give short courses and seminars like this one. And we have a large network of experts, investors, and companies. The next. And as you can see in this slide, we work with all kinds of innovations that come out of research at KI and that aim to improve human health. And in the current portfolio, approximately 15% of the companies are within digital health. And the next. So I just wanted to mention that all of our services are free of charge and we don't take any ownership in the supported projects or companies. And if you would like to know more, you can follow us on LinkedIn. You can sign up for our newsletter and you are very welcome to send us an email or give us a call or visit us at Innomedicum at Nanna Svartsväg 2. So with that, I hand the word back over to you, Lee, to tell a bit about the core facility for eHealth.
Yes, thank you. So the eHealth core facility, this is a support function for researchers who need support to develop or test eHealth innovations. So for those of you who are not familiar with the core facilities at KI, there are about 60 different core facilities, and they will provide services for research and everything from animal testing to biobanking. And the eHealth core facility provides researchers with a wide range of services in digital health. So these pictures are just meant to illustrate some of the examples. For example, we provide platform solutions for digital interventions. We can develop and test smartphone apps. We provide solutions for online data collection if needed, and we can also analyze and store big data. If you are more on an idea basis, we can help you with grant applications in the field of eHealth, or just discuss some ideas that you might have for future projects. So we also arrange workshops and seminars like this one. So if you're interested in knowing more about us, or you have a project that you wish to discuss, so please send us an email or follow us on LinkedIn to see upcoming events. So that was just a brief presentation of our two organizations. And I just want to say a few words on digital health or eHealth. What do we actually mean by this? Because this can mean a lot of different things. But in the context of this seminar, we have chosen to be inclusive, and basically digital health in this context are all digital services that are related to healthcare, and that includes both caregivers, consumers, or an integrated service with both caregivers and consumers. So if we look at caregivers, some digital services exist in-house. For example, that could be imaging analysis by artificial intelligence, for example, and that is something that consumers or patients will never actually use by themselves. That's just for caregiving support. If we move over to integrated services, this is where caregivers and consumers or patients share certain services. For example, that could be internet-delivered psychological interventions, and that is a platform, for example, where caregivers and consumers will communicate and both use the actual service. Moving over finally to consumer self-care, this is where consumers will use the services without caregivers. For example, this can be a smartphone app to promote health or physical activity. So we include all this in digital health in this context, and we believe that most of your products will actually fit into one of these examples, and that you can relate into this way of looking at digital health. So Åsa will now talk a little bit about the potential in digital health. Åsa, are you with us?
Yes, sorry, got the mute. Yes, so I started to say that it's interesting to see this broad range of products and services that are included in the definition of digital health. And I think we're starting to realize that we will actually need this kind of solutions to meet the demand of healthcare in the future with a growing and aging population. And that it's not a question about if we are going to implement these solutions, but rather make sure that we implement the right solutions in the right way. And this is what we'll talk more about in this seminar series. In this slide, I have listed some of the potential benefits of digital health solutions, starting with the potential for a more equal healthcare when it comes to age, gender, geography, economy, etc. Digital health solutions also have the potential to be resource efficient, both in terms of the personnel needed in the healthcare, but also in terms of reduced need to travel, for example, to get a doctor's appointment. Digital health solutions also enables personalized medicine that can obviously give better treatment outcomes and better quality of life for patients, both because it's possible to give the right treatment and avoid the wrong treatments. Digital health solutions also have the potential to increase the patient involvement. And that's also something that is important, because it's been shown that if the patient is more involved, the treatment outcome is generally better. And finally, digital health solutions have huge potential within prevention of disease. So to make sure that people don't even become patients. Yes. So you can change slightly. This potential is something that Sweden has picked up, and there is a vision, eHealth 2025, where the government said that in 2025, Sweden will be the best in the world at using these kind of solutions. And I think we're doing okay, but there is much more to do. Yes, you can take the next. And since we are based in Stockholm, I would like to point out that Stockholm has a very strong basis for development of digital health solutions. We have 4 strong universities with different focuses. We have world-leading healthcare providers, and we have a number of companies, both in terms of unicorns and established pharma and tech companies. And in the next slide, we can see that this opportunity is actually reflected in a large number of digital health companies. The picture to the left is developed by our colleagues at Stockholm Science City, and shows that in 2018 there were close to 130 digital health tech companies in Stockholm. And to the right you can see some examples of companies that we have supported at KI Innovations. So with this, I would like to invite our guest speaker of today, Nävås from Synergon. And as Lee said, you will talk about what kind of assets there might be in a digital health project and how these can be protected. So warm welcome to Christopher in Gothenburg, I believe.
Thank you. Yeah, I'm in Gothenburg today. So yeah, should I maybe start sharing my screen then for the presentation? Let's see. Yeah. So today we will talk about discover the values within your digital health projects, and especially related to the intellectual assets and the intellectual property rights. But maybe first just a short introduction of Synergon and myself. Synergon is a consultancy company primarily working with strategic advice concerning IP within the fields of pharma, biotech, medtech, and digital innovations. And we usually have a quite strong commercial focus, but we work quite a lot in projects with non-commercial innovation projects as well. And we primarily work towards academia and small and mid-sized companies as an IP department on demand. Yeah. We have 3 offices, one in Stockholm, one in Lerum, which is our head office where I'm at today. And then we have an office at the BioVenture Hub at AstraZeneca in Mölndal. And something short about me as well. So my name is Nävås. I'm an IP business consultant. I hold a Master of Laws in Swedish juristexamen and a master's degree in innovation and entrepreneurship in biomedicine. And I'm responsible for the digital innovation department at Synergon. And I'm primarily working with IP-related questions when utilizing digital innovations, especially within digital health. Yeah, so short, what what will be the agenda for today from our side. And the first part, we'll talk about intellectual assets. What are the assets and how do you define them? Then we will have a short discussion with possibility for questions. And then we will move on to how do we protect the assets, the different legal frameworks, etc. And then we will open up for another discussion and possibilities for asking questions. The basis for the presentation today will be your assets and the ways for you to protect the assets you own. We won't go in depth into assets that other owns, but you might use, such as freedom to operate questions and so on. We will probably have a short discussion about that during the last session in this series, especially concerning open source, since that is a relevant and often difficult difficult thing to manage within these types of projects. And almost all eHealth projects needs to address the open source questions. Yeah, so first of all, what's an IA or an IPR? So IA, intellectual assets, IPR, the intellectual property right. And the intellectual assets, we define them as defined intangible assets, such as knowledge, identifiers, data, etc., that is controllable. So to be an intellectual asset, this needs to be defined. I will describe this further later on. The IPR is the legal framework that provides the rights holder with a possibility to exclude others from using, distributing, modifying, etc., an intellectual asset. And this is important. Exclusion, not a right to use, but I will get back to that later on. And of course, you probably have heard about the term IP. And the IP is the general concept covering both intellectual assets and intellectual property rights. And IP stands for intellectual property. Yeah, so this is also an important question that we often got, especially from researchers who are more into social innovation or non-commercial utilization projects, or maybe just into doing new collaboration and publishing all their results. And that is nothing wrong with that. That's a very important thing to say, that's if you're not interested in any commercial utilization, then it's totally fine, but you should be aware of the intellectual assets perspectives. Yeah, so why should you care in a commercial utilization? That's a quite obvious question. If you cannot control your innovation, then why would anyone pay you for it? Why would anyone invest money in your innovation? And then it's likely to, if it's a good innovation, then it's likely that someone else will steal your innovation or copy it in some way. In the non-commercial utilization, then it's more a question of how would you like to have your innovation used? Maybe from a quality perspective. One typical example here is if you have developed a new drug, and this drug could be used for executions, for example. Would you like to have your drug used for executions? Even though you would like to release it free, open, accessible for everyone, you might would like to limit the use of your drug in executions. And the same applies to digital health innovations. In which settings would you like others to be able to use your innovation? Even if it's non-commercial, you can say, yeah, it's totally fine. We can have it open, totally open. But there might be cases where you think it would be unethical for use the innovation, for example. And in collaborations, this is really important to define the background data, to define the background information that you're bringing into the collaboration, and how you're able and how you are allowed to use the outcome of the collaboration after the collaboration is done. Are you still able to continue the research on your own using the results from the collaboration? Are you still allowed to publish everything? And are the other parties in the collaboration allowed to use your background data after the collaboration is ended, for example? So therefore, I believe that this is important for everyone, irrespectively whether you're using it commercially or non-commercially. So, defining the assets. If we say that all this land is your knowledge and you would like to share that knowledge or share that land with anyone, you need to define what you would like to share. That is creating an asset of it, defining the area of the land which you would like to share. That could be the intellectual assets, a specific field, a specific data set, a specific name, maybe an article, etc. But just sharing the information doesn't give you the right to limit others from using it. It only gives the others the possibility to use it. And if we take the land example, without any legal frameworks, the only way to protect your land is by sword. And therefore, we have created a legal system and a social construction that provides you a right to freely or nearly freely use your land, or at least have the right to exclude others from using your land. And that could be the IPR, the legal framework that provides you a right to exclude others from using what's yours. So in practice, what would this mean? Typically, when we had an innovation, the question that have been asked has been, okay, we have an innovation. Is this patentable or not? And that's a valid question for example, a new molecule for a new drug, or for a new type of technical improvement of a component, for example. But when it comes to digital innovations, they are typically quite complex. They have some insights. Upon these insights, we have code and algorithms. And maybe the code and algorithm create some kind of technical effect. There are different types of business models, including concerning different types of distribution models, etc. And also identifiers that separates this digital innovation from other types of digital innovation, creating the validity of the digital innovation. And there are also how your digital innovation or the digital innovation coexist with technical apparatus how it communicates with technical apparatuses that are third-party hardware or third-party software, or works in a for example, medical system. Yeah. So the question whether is this patentable or not becomes a bit too vague, or the scope of the patent becomes too broad, so it's not a patentable invention. So therefore, instead of having this one patent block, you need to understand how can each and every one of this part, this component, or this intellectual asset be protected and controlled. So the best way to discuss or to show how this is, how each and every part are controlled, I believe, is to adding different types of tags, for example, patent or copyright. We will discuss the different IPRs such as patent and copyrights later on, because these are measures that provides you the control to exclude others. It could be trade secrets, trademark, domain names, how you design your agreements, technical barriers, how do you solve the distribution, for example? Is it a cloud-based? Is it installed on the client's computers, for example, or smart devices such as a smartwatch? And of course, how do you position yourself at the market? And by using all of these in a strategic way, you can build a fence instead of building that one big block, and be more agile in your IP strategies. So how do you define an intellectual asset? First of all, you need to identify the general concepts in your innovation. It could be methods, it could be what you're trying to solve through a certain treatment model, etc. Then you can divide these into components and subcomponents. And by components and subcomponents, we mean how can you split up the method? The method might consist of different types of steps or processes. The method might be embodied in an algorithm, and this algorithm might be a component or a subcomponent to the method, because that's how the method is utilized. And you need to understand how these different subcomponents or components relate to different IPRs. And the two first parts will show you now how this can be done. And the last part will be in the end of the lecture, after we have discussed the different types of IPRs. So we have an example. We have a method for treating addicts. This method has a specific name. The method is implemented in an algorithm or through an algorithm and embodied in the source code. And the algorithm is defined in specific rules. So in this case, the general concept would be a method for treating addicts. This method has a specific name, and the algorithm is one component of that method. And a component of the algorithm is the code, and of course, the specific rules. So, first, do you have any questions or concerning this? Because this is like the fundamental parts of understanding how this should be divided. And each and every, I will show this later, but each and every of these steps will have connected specific intellectual property rights connected to one another that enables controlling them. So it's not just controlling the method, it's controlling the method, the name, the algorithm, the source code, and the specific rules. And there you can make strategic choices of what you would like to protect, what you would like to keep as proprietary, and what you would like to share in an open environment. So, oh, sorry. Any question concerning that?
Hello, this is Socrates.
Hi, Socrates.
Thank you for Christopher for this presentation. I think it's very interesting and important for us, especially when we are researchers working around computer applications and computer systems. I have a question regarding the legal protection when it comes to consortiums.
Yeah.
For example, we are participating in several European projects, and we have one system that has been developed and owned from Karolinska Institutet, a clinical history taking program. And there we have to provide data from our system, but we would like also to protect the way that we were going to share this data and also to protect the system as a whole. So when it comes to the interaction with the other partners in the consortium. So is it something that is covered here with these?
Yeah, I think I will talk about this a bit later on, but just to answer your question, because I think it's an important question.
Yes.
Because it covers the collaboration between different universities in different countries, or maybe universities and companies.
Yes.
Because this is the tricky part when it comes to IPRs, which we will talk a bit about later, is that these are typically national legal frameworks. That means that even though in some cases you can rely on not having a contractual bond between the different collaboration partners, these types of cases, it becomes really obvious that the agreements between the parties are central, because you have partly then in this case you probably would have data as the core intellectual asset, and the data could, if the data is structured, could be defined as a database in the legal meaning. And the database protection is primarily a European protection. There are database protection in a few American states, but otherwise it's primarily for European citizens and companies. With that said, even though this is a EU regulation providing the protection for the databases, the practical implementation of this differs quite a lot. For example, if we take Belgium or France, they do not agree that public authorities as a publicly owned university can own a database. while in Sweden, we are quite convinced that databases could be owned by universities. Then you have the second question. Databases are not necessarily covered by the teacher's exemption, or we do not know yet.
Yep.
So that's the second part. Who is the right holder? Who's having the right to exclude others? And this is primarily based on the question whether the database is a research result or research material, because that has been in the discussion, at least in like the legal discussion, whether it should be considered to be owned by the researcher or the university.
Mm-hmm. Mm-hmm.
So my tip in this case is to ensure that you have good legal structures in the agreements in these collaborations.
So we define exactly.
Yeah, define exactly who owns what, who will own which results, and how are what rights to use these results do the different parties of this collaboration have.
Mm-hmm. Mm-hmm. Thank you, Christopher.
Christopher, we have one more question. Alexandra has raised her hand.
Yeah, perfect.
Please, Alexandra.
Thank you. Hi, Christopher. Alexandra. I'm a psychologist. I work with the issues related to the dynamic assessment, and what I'm struggling with is the problem that we as researchers are funded by basically the money that comes from taxes, and we are obliged to share what we have come up with in an open access way, and that's something that is a part of our agreement with the funding agencies, and we're supposed to share what our findings publicly. And my big problem here is to what extent, what is really that I am allowed to protect in this way. That I got, for example, I got funded to create an application, mobile application, and can I now claim the rights to it if the funding for developing it actually came from taxpayer money, right?
Yeah, thank you for that question, because it's a very important question that many researchers face, and we get it not maybe on a daily basis, but at least on a weekly basis we get that question, and the basis here is what does the requirements or the obligations in the funding states. And if the funding states this needs to be publicly available on an open access basis, then the question is what is needed to be openly accessible. And therefore this part of the work is really important to define the different assets. What are the assets resulting from this specific work? Because, I mean, the funding you have received and the research you have conducted is likely just a part of your whole research. And you have built a lot of knowledge over the years that was prior to this specific funding. And then the question is, which parts has been part of the new funding and what does the funding states? From a strict legal perspective, you are obliged by the agreement that you enters. And when you receive funding that are conditional in this case, then you have entered into an agreement. If there were no agreement, then the legal text only covers patentable inventions. So that we can have as a basis for our understanding. If the invention is not patentable, we have no legal support for claiming anything. We have a legal support in maybe how the court has acted earlier, and a legal support in the legal discussion, but not from the law as such. So we have a law based in 1947, I think, or 49, which covers the teacher's right to their inventions. And if you read the basis or the background argumentation for that law, it's quite clear that the researchers should be free to do whatever they would like with their results. With some exceptions, of course, but that's the baseline. And with that as baseline, it's also important because that's the freedom of the researcher. The researcher should not be forced by for example, a lead at the university or university board to do, for example, more commercially relevant research or so on. But it's also the right to the researcher to choose when to publish. When are the results good enough to publish? So that's also another important aspect in this. You might be obliged to publish, but when are you obliged to publish?
Perhaps I can add to that most universities have their IP policy, which is sort of in addition to this law about the teacher's exemption. And in the IP policy, there is a section about software and how to handle those assets. So we can distribute that, and it's also available on the web. So there are some certain rules about educational material and software.
Great, thank you so much.
Yeah, and back to that once again, it's a difference often between the software and the treatment model. The treatment model are often implemented in the software. So there are also one important factor to have in mind when doing the mapping of intellectual assets, that the intellectual assets could be for example, the treatment model, the processes, etc. And then the implementation in the software, there is the KI IP policy, right, Åsa? Or
yes.
Yeah.
Yep.
So therefore, that is the reason why this is important to be aware of the intellectual assets, and we will talk about the IPRs soon, how to protect those assets. But from that perspective, especially from the IP policy perspective, I think this is really important to be aware of where is the different like borders or lines between who owns what and what rights do you have to utilize.
Can you mention, Christopher, if there are any other specific reasons, because it seems important to keep track of the assets within a project relatively early, and obviously to make sure that you don't use something that is someone else's. What about valuation of projects, for example? Can you comment on that? If you want to raise money.
Yeah, one important thing here is that the one who has created an intellectual asset will be the one who owns the intellectual asset, typically. And if you have, for example, a master's student or a PhD student developing something within a group, or you have a short-term collaboration with a third-party university, then there might be obligations or rights to that specific asset that you intend to use or that you have already implemented in your innovation. That might be, there might be co-ownership or sole ownership by others. And when entering into the innovation process or utilization process, these persons might be able to limit your use. And the nature of intellectual assets are typically that they will become more worth when they are implemented in an innovation. That means that people would like to get paid if it becomes relevant in an innovation, or more paid maybe. That means that being aware of this in an early stage make it easier to manage this contractually. I've been involved in cases where this was not managed contractually in the beginning, and maybe it was a postdoc who did some research during a year, and then 3 years later we need to track down that postdoc who's now on the countryside in China, which is almost impossible to track down because the person has dropped all scientific ambitions. So therefore, this is really important to manage in the beginning. It's also that it could be, for example, one other example that's good is when the group wants to go in 2 different directions. And then it can be like a dead project, since no one is, everyone is prohibiting one another to use the intellectual assets created within the project, based on uncertainties concerning the ownership of the assets. And this becomes really difficult, especially when trying to raise capital, because an investor would like to know that you own the rights if they would like to invest. Yeah, I think that's that covers most of it.
Thank you.
Do we have any additional questions, or would you like to, should I continue?
I think you can continue, and then we'll get back.
Yeah, great. We will have a session in the end as well with questions. So the IPR, the legal framework for protection. So there are a number of legal frameworks. I have listed like the 8 most common here. I've actually skipped one, which is actually the most common, and that is firma, the company name, which is a separate set of rules. And these are all different types of legal frameworks. And I think before discussing each of these, or we will discuss 4 of them because we won't have time to discuss all, and we will only discuss them briefly because we could have like a whole semester course on patents, and we would not have been able to cover everything. So this will be only very, very brief, and I strongly recommend you, if you have any questions concerning these, to reach out and just send me an email or something, because these questions are typically very complex and or these frameworks are very complex with a number of rules, and they are also nation specific, which means that all the set of rules are different in each country. Yeah, but first, 3 things to have in mind. And the first thing is IPR provide no right to use, only exclude others from using. I think I've said that quite a lot of times today, but this cannot be enough emphasized. For example, if you have source code, and that source code contains a source code that you have received from others, then you probably have the right to the source code and how you have mixed the source code libraries in new ways, but not necessarily you have to right to use this source code or distribute the source code. I will show you an example later on. If no IPR framework applies, one cannot on a legal basis limit others from using that AI. The most typical example here is data. I said before that databases are protected by the database protection, but the data as such is not necessarily protected. And this is an important thing to have in mind, that you have to differ between the collection of data and each data point. And if you have an invention, for example, and you cannot patent it and not use any other legal framework, then you cannot protect that concept or limit others from using that concept. Then we have each framework has specific rules and legal logic that only applies to that specific IPR framework with jurisdiction-specific peculiarities. And you will notice soon that the 4 IPR frameworks that we will discuss briefly have very specific rules for what they protect, how you receive the protection, the length of the protection, etc. And for example, in collaboration, each of these frameworks has specific rules of what types of rights you can share and what types you cannot share. And since I have a background in law, and our favorite police professor, G.W. Persson, has once stated that lawyers can't count, we have a fourth key thing to have in mind. IPR enables sharing of information. IPRs are not interested if you're having all the information for yourself. Then you have no risk of others stealing your information. But as soon as you would like to share your information, then IPR starts apply. So that's one of the most important things to have in mind here, is that IPR enables sharing of information. And I will get back to you to this when we talk about patents, which we will do now. So a patent protects a concept. A concept could be a method for or an apparatus. A quite famous patent describes a concept of putting the eye of in a sewing needle, the eye at the tip of the needle, which enables the sewing machine to pick up the thread on the under thread in the sewing machine. it protects the concept of placing the eye in the tip or top 2 centimeters of the needle. It's not necessarily, sometimes the concept is very well defined, that it has to be placed on a certain place. In other cases, it's more broadly described, that it can be placed anywhere between these 2 set points. The protection is defined in the claims, and the claims of a patent you will find in the end of the patent document. And if you cannot read from the claims that this is protected, then the patent do not cover that embodiment of the invention, for example, or that part of the concept. The protection lasts for 20 years from the date of the application. Since we're talking about digital innovations here, this is strict. If we talk about pharma, there are a possibility to have the 20 years extended up to 25 years, but that only applies to pharma. And it's only a national protection. If you've heard anyone claiming that they have a worldwide patent or world patent or so on, then that claim is false, because patents only covers the national jurisdiction where the patent is valid and registered. So if I have a patent in Sweden and not in Denmark, everyone can use the concept in Denmark, but I cannot exclude them from using the concept in Denmark, but I can exclude everyone from using the concept in Sweden. And this is one of the important part. The application becomes public after 18 months. And this is the whole basis for the patent system, that you trade your 20 years of exclusive use of the concept for publicity. You cannot keep a patent secret. So the patent requirements are, it has to be new. It cannot be known anywhere in the world. If it's disclosed in the contact pages at Östersunds-Posten or in a small tech magazine in Kuala Lumpur, that's a novelty destroying action. So if the invention is patented or disclosed in anywhere in the world, that destroys the novelty of the patent and the invention is not any more patentable. Therefore, before publishing in, for example, a research in a medical journal or any other type of research publications, or sending a poster to a conference, or having a preprint, that are all novelty destroying actions. So if you would like to investigate the patentability possibilities of a certain invention, please do that before submitting your manuscript or submitting your poster to the conference. It has to have an inventive step. The best way to describe this is saying that 1 + 1 cannot be 2. You cannot add two, you cannot combine 2 known aspects and having the only reasonable result of that. It must be some way inventive and unexpected. The difficulty here is often that things become expected when you have seen them. It becomes obvious for the one who is skilled in the art that this is obvious after you have seen it. So this is often a difficult requirement to investigate. And often here where the patent agencies or the patent offices have opposed the registration and say that the invention is novel, but it lacks in inventive step. And then it has to have a technical effect, and that is, it has to have some kind of effect in the real world. And this applies especially to software-related inventions, and where software-related inventions often are more difficult to get approved as patent or having the patent granted. Yeah, and the difficulty here is that it's the court has been quite inconsistent when defining what technical effect is. It's actually one of the courts in England, the judge said, or the Supreme Court in England, one of the judges said that technical effect is like elephants. You cannot describe them, but you know what it is when you see them. So therefore, the technical effect is often difficult to argue for if it's not accepted from the beginning. But there are often, if it contains, for example, image analysis and different types of treatment models, etc., then you often can claim some kind of technical effect. So, more from a strategic point of view, the patent timeline. If we file a patent today, it will be published after 18 months and granted, maybe if it's a software innovation, then it's typically 4 to 5 years until it gets granted in most countries. There are some nightmare countries such as Brazil, which has like 14 years until the patent gets granted. The time from where the validity counts is from the application. So you have 20 years from the application until you have if the patent gets granted until the protection is ended. So what should I think of when I having a patentable invention that is software related? You have to be aware of, is it version specific? That means that, is this specific only to this version, this beta version, for example, and how soon will this be obsolete? For example, if it's only related to the beta version and you think that will be discarded before the 18 months, then maybe it's not worth to spending a lot of money on a patent application. However, do you believe that it could be a part of the core functions of the software that will stay alive for numerous versions or stay part of the invention? Then a patent probably should be at least evaluated, or the patentability should be evaluated. Yes, then the opposite of patents are trade secrets. The trade secrets protects a company's confidential information from corporate espionage, and employees or collaborators from disclosing information from others. That means that this is when sharing information, for example, with employees or collaborators. Then you have legal measures to if these employees or collaborators breaches their confidence. By company, one important thing here, it could be what we call in Sweden simple company or simple enskild näringsidkare, sole entrepreneur, or I don't know the English word actually. Therefore, this applies in some cases for researchers when converting their results into a company. Yeah, and to be entitled to this protection, the holder must have taken action for maintaining the secrecy, typically having NDAs in place and other types of structures for making sure that the information is kept secret. It provides a quite strong protection as long as the information is secret. And with strong protection, we mean you can take quite strong actions, especially concerning damages and fines towards the ones who are breaching that confidence. And it could also be, even if it's for example an employee changing company and sharing information with a new employer, that employee could be held liable for the damages and not the company. It could also be the new employee's boss that can be held liable for those damages. It's not limited in time, but again, as long as the information is kept secret. And of course, secrets concerning serious crimes are exempted from this protection. And this is really important in some cases to state that if you are participating in a collaboration where you receive trade secrets and these secrets are concerning serious crimes, then of course you're not obliged by keeping secret about those. But that only applies to the correct authorities. You're not allowed to go to media with that type of information. You have to go to the police. And it primarily applies in US and in some extent, in EU and in some extent in US. Then it applies in several other countries, but then they have it as unfair competition regulation. So they mean that this is part of the unfair competition. For example, Norway have or at least had an unfair competition approach to this. Yes, and then
Christopher, may I
just
add a question? If something has been treated as a trade secret, can you then, is it still novel and inventive? I mean, is it still novel? So could you, if you treat it like a trade secret, could you then decide to patent protect it?
Yeah, and there are actually a combined way with patents and trade secrets, because you have 18 months until your patent get published. During that time, you can withdraw your patent application. That means that you can keep the information, keep the invention novel, as long as you keep the invention as a trade secret at the same time. And then you can refile that same application. So you can have a patent application which is secret for a longer time, but then you lose the first priority date and you get the later priority date.
Thanks.
Yeah. Copyright then. It protects artistic and literary works from from illicit copying, but also computer programs. And it protects the expression, not the concept. So patents, the concept, not necessarily the expression. Copyright, the expression, not the concept. So let us show you, let's show an example. Anyone dare to say what this piece of code does? Feel free to just speak out. It's a...
Yeah. Hello, this is Stefano.
Hey, Stefano.
It's for reversing, how do you say, the status of a Boolean variable. So if it's false, it became true and vice versa.
Yeah, exactly. And Stefano, could you describe this one as well?
Yeah, I suppose it's doing the same things, but with a different expression. So it means that if you just change some of the character in the lines and how things are located, maybe the copyright is not, how do you say, broken or something like that.
Exactly. It's not a patent. It's not a copyright infringement in these cases. It's three embodiments of the same concept. The code is executed a bit differently in each of or the function is executed a bit differently in all these three cases, but they are all three different works from a copyright perspective.
Sorry, I would have an additional question about that. But for example, this code is in a specific programming language. And I was wondering if I'm maintaining the same expression, but using a different programming language, I'm infringing the copyright or not, because it was done in a different way, with a different language.
Yes, so that was almost like it was planned, because that is the next bullet point in the presentation. Because the protection provided is against direct copies, of course, but modification and translations as well. So just changing the language means a translation. So just changing language is a translation that is a copyright infringement, or would possibly be a copyright infringement. Then one important thing here is that your new translation is your own copyright. So you have the right to limit the original rights holder from using your translation, while the original rights holder are possible can limit your use of the translation or the original code.
Sorry, I would have a question, because in general, if you are a programmer, you have a specific style on writing expression and the code as well. But then how you could, how do you say, decide who is the first one that applied this expression for doing this code? Because it's maybe someone is applying the same expression that was used in a language developed in 60s or 70s, such as a C, and applying to the same, how do you say, style or writing style to other languages that are new. So yeah, it's something like a problem that you are not able to identify who is the first that were using this expression. Yeah, this expression for this code.
Yeah, and no authority checks this. So it's up to the coding community or the coders themselves to in that case, sue for copyright infringement. So in that case, if someone can prove that you have used my code for and made this modification or translation of the code, then in that case, you've done an infringement. But then they need to prove that that has been the case, and not necessarily that you have just known this concept and by this concept created this piece of code on your own. So the risk here is more for Google and that kind of actor, or mid-sized, for example, car manufacturers and so on, not necessarily smaller companies. Because the protection, as you asked there, maybe from the 70s, but the protection is valid 70 years after the death of the author or creator. That means that I think all code that is still working, at least, or is still used, are still under some kind of copyright. And this protection is actually possible to enforce in most countries due to different international treaties. So this is probably the most spread and most the part that the IPR that is most harmonized, actually. Yeah, and no registration is necessary in most countries. And back to your question again, copyright is the basis for open source and Creative Commons. So all libraries shared under an open source license is covered by copyright, and the requirements for the use is stated in that license. Yeah, so just some short words. I know the time is becoming short, but just some things short about trademarks. The trademark protects a distinguishing feature of a specific product or service. These features could be name, slogan, logo, design, colors, melody, scent, you name it. It just needs to be a distinguishing feature that is possible to put on print or have a graphical representation. For example, melody needs to have some kind of music sheet connected to it. For example, hemglassmelodin. And the scent needs to be defined chemically. The trademark may not describe the product, so apples cannot be protecting apples, but it can protect computers because apples do not describe computers. The scope of the protection is limited by the classes and the needs to be used in order to be maintained. In Europe, during the first 5 years, in the US 5 years as well, in China 3 years, for example. The protection is gained through registration or establishment, and it's a national or regional registration. That means that in some regions in the world, for example, EU, we have a regional registration. There are 2 parallel systems in Africa, one in Eurasia with Russia, Kazakhstan, etc. And the registration is typically valid for 10 years if used. And then it's possible to renew that registration. So, moving back to defining your AI, I said that we would get back to this. How do these subcomponents relate to different IPRs? So you remember this image. We have the method, the name, the algorithm, the code, and the rules. So then we need to add the different tags that builds the fence. So we have possibly patent on the method, maybe a trademark on the name, and then it should probably be that name should probably be used in research articles, etc., to have a good connection between the name and the research. The algorithm are typically protected through secrecy, and the code through copyright and secrecy, or secrecy maybe, and the rules through secrecy. So if you are doing a research publication, maybe you would like to publish the method, but the specific algorithm are maybe not necessary to publish. Yeah, some concluding remarks before we having short time for questions. So all utilization, from my perspective at least, all utilization project needs to have an awareness of the intellectual assets used and any rights related to these assets. This specifically applies to collaboration research when utilizing those results, or continue with the research within or outside that collaboration, but within the field using those intellectual assets. IPRs enables openness with conditions that you can set. Under these conditions, are you allowed to use my intellectual property rights? For example, you're only allowed to use these intellectual property rights if you use them in this setting, or as or with a or in whole, for example. You're not allowed to split this in different parts. And once again, the IPR only provides a right to limit others, not necessarily a right to use. And all IPR frameworks have their own peculiarities, as you have seen. And we can discuss that a lot more, but I don't think we have time for more in-depth presentation of the IPR frameworks. So thank you. Is there any questions?
Okay, I have a quick one, Christopher. I was wondering which is the most underestimated intellectual asset?
That's a difficult one. Of course, it depends from project to project. But from my perspective, I would say that typically the data sets are underestimated in relation to at least in related to the impact that the rights to these data sets could affect the project and the rights management, because that could affect the project quite a lot. The other most underestimated from a risk perspective, if we take that first, because that is the easiest, is probably the source code, because there's a lot of legal risk connected to source code that can be quite easily managed, but this is often foreseen by the entrepreneurs. Otherwise, the more general concepts are often quite underestimated in their value for the project, but in some cases overestimated in how they are possible to be protected.
We have a question also from the audience. Fotis, please.
Hi, thank you.
Hi.
Unfortunately, I just joined later than the start because of emergency teaching situation. But I'd like to ask about the patent of a concept. In our case, with digital technologies, you have an experiment and you have a pretty good idea of what you are expecting. But isn't it so that you have to include some preliminary results in order to be able to get a patent for a concept? Because you don't really know that it's going to work, that you're going to have good algorithms later on.
Of course, you need to show in some way, or make it likely at least, that a specific claim works, or a specific claim has the function that you claims. So in that extent, you need to show that, or show the capability. But this is not necessarily always that strict, how you are able to show it. For example, within image analysis, this is often a bit more loose when it comes to proving that it works. It's often, if you file a patent for this, it's almost it's expected that it will work and that you have tried it. But on the other hand, you typically show images that prove your point that this works.
We have perhaps, I mean, it's already 1 o'clock, but if anyone has a last question for Christopher. No. I would like to remind you all that in 2 weeks, we will talk about different options for implementations. So I hope to see you all there. And me and Åsa and Christopher, thank you all for today. And please, if you have any additional questions or anything, don't hesitate to contact us. Or if you want us to get you in contact with Christopher, we are happy to do so.
Thanks.
I think we can say goodbye then.
Yes, thank you so much for today.
Thank you.
Thank you.
See you in 2 weeks. Bye.
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 Thank you.
Jag ska bara
Hallå?
stänga av recordingen här.